So in our lesson today, we're going to multiply monomials and polynomials instead of adding or subtracting. That's what we did in class. So just a reminder, when you add or subtract, the exponents do not change. These are the only two notes for today other than examples, but they are very important. So for example, if I have 3x squared minus, or we'll say plus 5x squared, I'm going to get 8x squared. Notice here that my exponents are the same because I'm adding or subtracting. All right, also, when you add or subtract, you have to have like terms. So if I do 2x to the fifth plus 3x squared, I cannot add those because one is to the fifth and one is squared, which means what you see is actually your final answer. All right, when you multiply, it's not quite the same way. So if I do 3x squared times 5x squared, that is going to be 3 times 5, which is going to give me 15. And remember, x squared means x times x, and this x squared also means x times x. So altogether, that means I have x to the fourth. So when you multiply, notice that my exponents are changing now. I have a new exponent of 4. Notice how that is different than when you added or subtracted. Also, when you multiply, they do not have to have the same base. So here I could multiply 3x to the fifth times, 2x to the fifth times 3x squared, and I would get 2 times 3 would give me 6, and this would be x to the fifth, which is 5 x's, plus 2 more is x to the seventh, right? We could expand that out just to see. This is 2 times, I could write 5 x's. Remember, when in doubt, expand it out, times 3 times x, and that may be a little easier for you to see all of the different pieces. 2 times 3, and then 5, 6, 7 x's. All right, you need to have these in your notes because if you don't understand this concept, then none of the rest of the stuff is going to make sense. So if you need to rewatch this little part of the video to get all this in your notes correctly, do that. Make any additional notes that you need to. Okay, so we're going to do 1 or 2 examples of each kind. This first set is just multiplying monomials. So this is when I've got kind of some simpler things going on. If anytime it says product, that just means to multiply. All right, so example A here, if we want to do the when in doubt, expand it out, we can. That's going to give us 6 times x times x times x times negative 4. And then there's 4 x's. And when I regroup, I've got 6 times negative 4, negative 24. And 1, 2, 3, 4, 5, 6, 7 x's, so x to the seventh. Example B here is very similar. When in doubt, I'll expand it out. Times y times 7 times x times y. Group my similar things together. So 5 times 7 is going to give me 35. I have 1x, 2 x's, so x squared. And then 1, 2, 3 y's, so y to the third. If you have any questions, you need to write them down or put a little star in your notes to ask about this specific example in class tomorrow. All right, this second set is very similar, except you may notice now that instead of multiplying 2 monomials or 2 terms that are all squished together, now I have a small piece that's multiplying by a polynomial much larger. So let's zoom in and look at question A together. Okay, like you've done before, the parentheses should make you think to distribute. And notice there are 3 terms on the inside, so we're going to be distributing 3 different times. Now I'm going to go ahead and write out 3 separate multiplication problems so we can really see what's going on. So this first multiplication problem is 3x times 3x squared. My second multiplication problem that I see is going to be 3x times 6x. And my last multiplication problem that I've got here is 3x times negative 5. So now notice that's just me writing out the distributive property. And I'm going to go back and just try to count up and see what I have in each piece. So if I look just at this green part, I have 3 times 3, which is 9. And then I have 1x here and 2 right there, which is going to give me x to the third. If you aren't sure, you could write this out as x times x times x, and notice that there are 3 x's all together. For the red part, I've got 3 times 6, which is 18, x times x, which is x squared, and because that answer is positive, I'm going to put a plus sign in the front. And then my blue, I can do the 3 and the negative 5, which gives me negative 15, and there's just one x there, so I'll just write 1x. And that is going to be your final answer, because now I have 3 separate terms that are all have different exponents, so I can't add or subtract them together. All right, example B, same idea, but now we have more variables. So 2xy is still going to be distributing, and there's 3 parts on the inside. 5x squared y, positive 3xy squared, and positive 7xy. So if I do my first multiplication, I'm just going to write the multiplication problem out. Let's write out my second multiplication problem, 2xy times 3xy squared. And then my last one, 2xy times 7xy. And now we're just working out each problem individually. 2 times 5 is 10. I have 1, 2, 3 x's, so x to the third, and 2 y's, so y squared. 2 times 3 is positive 6, so plus 6. 2 x's, so x squared. 1, 2, 3 y's, so y to the third. And last part, 2 times 7 is 14, and it's positive, so plus 14. X times x, x squared. Y times y, y squared. And notice, none of those have the exact same combination of letters and exponents, so I can't put them back together, which means this right here is my final answer. I really, really need you to put stars in your notes if you're confused on any of these examples so I can show you better ones tomorrow in class. All right, so here's another example that's just a little bit different. Notice on this example, we've got 2 sets of parentheses. And unlike what we did yesterday, this is not addition or subtraction. This is still multiplication, except it's kind of hard to figure out what you're distributing. So it looks like we're actually having to distribute this entire parenthesis. And when we do that, the way that I like to say that is that we're going to double distribute. So notice that there's a 2x here that's going to distribute to both parts of the second parenthesis. And there's also going to be a 3 that distributes to both parts of the second parenthesis. So I'm going to back up and I'm going to do the 2-part first. So if I distribute that 2x, my first multiplication problem is 2x times 4x, which gives me 8x squared. And then 2x times negative 5 is minus 10x. Now my second distributive problem is to distribute the 3, which is going to give me plus 12x. And then 3 times the negative 5 is minus 15. And now here we actually do have one additional step, and that's to see if there are any like terms that can be combined. And you may notice that these terms in the middle both have an x with them, so I can combine those to make my final answer 8x squared plus 2x, right? I've got negative 10 and positive 12, and since we're adding, the exponents are not going to change, and then minus 15 in the end. So notice if you have 2 parentheses, we're going to do what's called double distributing. All right, our last example for today is about area. Yesterday we talked about perimeter was when you add all the sides. And today when we talk about area, to find the area of a rectangle, we're going to multiply. Or you can write down the formula that area equals length times width. So when I do that, I'm just going to set up my equation. Area equals length, which is 2x to the fifth, times the width. And because the width is this whole thing, I'm going to use parentheses so I can keep it all together. And then we're back to what we just did, distributing. So 2x to the fifth times 3x to the third. And then distribute one more time, 2x to the fifth times 4. And that's going to give me 6. 2 times 3 is 6. X to the 5, and then there's 3 more, so that's x to the 8th. Plus 2 times 4 is positive 8. X to the 5th. So there's my final answer for the area on this question.